Am I good? Okay, great. So I'm going to give you an update on the Biogeochemical-Argo Steering Committee, and I'm going to update you on planning for construction of a global array of profiling floats. So OCB has a Biogeochemical-Argo Steering Committee website. The members, the ones I circled, I believe, are at the meeting. And raise your hand if you're on the BGC Steering Committee. Yui, Brendan Carter back there, Melissa. I haven't seen Melissa. Steve Reiser will be here later in the week. Meg is here. I'm here. Yui, Lynn Talley will be here later in the week. She's not going to be here. Oh. So OCB has had a long history. The OCB is 13 years old, and in the third year we had, I think, the third science workshop, and it's a long process building these kind of programs, but it's been 10 years since the workshop in Moss Landing on observing biogeochemical cycles at global scales with profiling of floats and gliders, but that has led to the current ongoing program SOCOM, which is deploying 200 profiling floats in the Southern Ocean. Has been very successful. Paper in Nature last week, if you didn't notice. Given that this has been a day talking about oxygen, I wanted to make a point about oxygen. So if you go to the World Ocean Atlas and query for the number of oxygen profiles that have been made from ships that go to at least 900 meters, which gets you through the bottom of the oxygen minimum zone, and also gets you off the continental shelf, because I'm talking about open ocean here. The history of shipboard profiles, there was a maximum in 1980, the solid years of observing oxygen, and today we make less than 10 times that many oxygen measurements, was apparent in some of the plots that were shown today. We just don't observe from ships anymore. The flip side is profiling floats are now making almost over 2 times more profiles than are made from, were ever made from ships to 2 kilometers depth. The program I'm going to talk to you about today would strive to make 40,000 oxygen profiles each year. The data is of extremely high quality. This is a paper that Seth Bushinsky wrote a year or so ago, looking at all of the profiling float data in the Southern Ocean in different regions, the subantarctic zone, the polar Antarctic zone, seasonal ice zone. You can't do this from a ship. You can't get a seasonal cycle in the Southern Ocean. Most areas, we just don't go to sea in the winter from ships anymore. Data is very high quality. The program I'm going to describe in more detail will deploy, I don't even have a picture of a profiling float in my talk, I don't think. But profiling floats equipped with oxygen, pH, nitrate, chlorophyll fluorescence, particle backscattering sensors, and radiometers for downwelling irradiance. So we're talking about building an array that will enable the community, and all of the data that I'm showing is publicly available in real time. That's the history of Argo data. And all of the data, the pitch I'm going to make to you is that we want to build an array. We're striving to build an array. You will be the users of the data, not the people that build the arrays. So globally available. So the OCB workshop led the way. It was one of the first planning workshops. Led to the development in 2016 of the Biogeochemical-Argo implementation plan. It's an international plan. It has a goal based on observing system simulation experiments of deploying 1,000 profiling floats with oxygen, pH, nitrate, and biooptics. A plethora of science goals that you can do with this. I'm actually not going to talk a whole lot about science. I would encourage you to read the implementation plan, but you can look at changes in carbon cycling, carbon flux, changes in OMZs, change in upward nutrient flux, acidification, the biological carbon pump, phytoplankton phenology, many, many papers written on these. And in fact, if you go to the program website, biogeochemical-argo.org, you will find a bibliography of hundreds of papers written using profiling float data to look at these processes. As well, it applies to management of living marine resources, carbon budget verification. The key point is that 1,000 floats have an average lifetime of about 4 years, requires sustaining an array of about replacing the array at 250 floats a year. And historically, the US has done half of half of the Argo array, which implies building an array that is sustained from US funds at about 125 floats per year. So in a very compressed time frame, NSF had an announcement, came out last December, the Mid-Scale Research Infrastructure 2 announcement. We call it MBARI. And it's for individual awards, $20 million to $70 million. They are anticipated up to 5 years. I highlighted this section. This program is really an equipment proposal. It will not fund science. Science, it does not support proposals for science research. Sounds a little odd from NSF, but it's to build a facility that will enable you to do science research, okay? And so the program was announced in December of 2018. Pre-proposals were submitted in March of 2019, and there was a down select of the submitted pre-proposals, and it was announced to us in May 2019 that we had passed through that gate of the down select, and there are now, across all of NSF, 13 of these proposals competing for as many as 6 awards, so, which is pretty good. And so the proposal that we wrote, Mid-Scale RI2, Biogeochemical-Argo, a global robotic network to observe changing ocean chemistry and biology. Pre-proposal, it's a consortium led by myself, University of Washington, Steve Reiser, Scripps Institution, Lynn Talley, Woods Hole, Susan Wafels, and Princeton, Jorge Sarmiento. The proposal is for 500 BGC floats with that sensor suite. It's a $49,400,000 proposal over 5 years, and as I said, one of 13 selected to submit a full proposal. So people keep asking me, is this funded? It's not funded. It feels a little premature to talk about a proposal, but if it is funded, the key to the success of this is going to be people like you doing the science. And so I really want to talk about the ways that you can then interact with us now as we go forward on this proposal. So there are, in addition, we were limited to 5 PIs, and so there are a number of people that in a considerate world would be co-PIs on the project, but they're listed as senior personnel. Heidi Cullen, Andrea Fassbender is here, George Matsumoto, Yui Takeshita is in the back, Allison Gray, Todd Martz, Sarah Perkey, and Rue Nicholson is also here somewhere, right there. A great group of people building a system, and again, I want to make the point that all of the data that this system would generate would be available, quality controlled in real time. So, you know, the plan that we have is to build an array that looks about like this. It's global in extent. The coverage favors some historical areas that the US focuses on in Argo. The goal is basically to have a 1,000 float array. This is half, the US half of the 1,000 float array, and there are assumptions made here. For example, US does not deploy many floats in the Western North Pacific because China and Japan take care of it, so we have down selected a bit in the Western North Pacific. We have more floats than 50% in the Eastern North Pacific because that historically has been an area that the US has emphasized, and other than Canada, there will not be many international partners in that region. Continues, the US has a large presence in the Southern Ocean, continues that, and so on. So the proposal would argue, is built on a slow ramp up to this 125 floats a year that sustains a global array. I want to make the point, though, that the science that we're writing for this proposal has to be science that you do in 5 years, or the 10 years that the floats operate. It's not about decadal scale science at this point. It's about getting seasonal cycles, interannual variability, regional variability in processes in the ocean. We have to write a proposal that will be successful with essentially one shot of money, although we'd all like to see it. I'd like to see it continue anyway. So it starts deploying 60 floats a year, goes up to 125. The trick in the proposal, as opposed to your normal NSF proposal, ship time here would come directly out of the budget for the program. So this is built on using other people's ship time. Okay. So we essentially have very little time to deploy. And so there will be a very strong collaboration with programs like GoShip, but also, again, the nexus with the community is your cruises. Okay. So this is sort of a projection. The yellow lines are planned years, P16, GoShip line 2022. There's a P2 line here. You don't see that. It will be in the first year. So we're planning. We'll make available our schedule of deployments so that you can start thinking now about writing proposals, if we get funded, to start to do things. So the green would be the year one deployments of the cruise. So there is a GoShip cruise across the North Pacific, a GoShip A12 line down the North Atlantic. Australia has a series of cruises in the Southern Ocean that they plan in that period. And that would about get our first 60 floats into the water. And we will just chug through every year doing something like this, making our plans available, receiving input through the OCB subcommittee from you about information cruises you plan, opportunities to, if there were upcoming programs like exports, for example, that you could interact with, and so on. But it will be a communal effort if this goes forward. So how can the US OCB community help and participate if the proposal is successful? And keep in mind, this whole thing's due August 2nd. It's not funded yet, but this is something I would be a little annoyed if somebody came and told me there was a giant proposal and we didn't talk to you about it, and you were expected to participate. So here's, pardon? So if the proposal is successful, be prepared, to write proposals to use the data stream. And I want to make the point, there's a strong data stream out there now that exists. Use that. So all of the Argo data is freely available. Talk to me if you don't understand how to access it, but all of that oxygen data, for example, that I showed from Seth Bushinsky's papers, all in the public domain. Argo data is available within 4 hours of coming off the float. There are 300 oxygen floats in the world not systematically deployed, but the SOCOM program has close to 180. Most of the floats only have oxygen on them. There are maybe 120, 140 floats that have nitrate, for example, and pH on them. They're international, about half, there's some, yeah. And mostly, I didn't show the map, but they're mostly the SOCOM floats in the Southern Ocean at this point. So provide input to committee members regarding deployment options, opportunities, what you might think are priority areas, because again, it will be the community doing the science. Right there, I showed a group of PIs, and we will all be doing science with this as well, but this is not just for the PIs. This is a community US array, a global array, an international array. Comments to the committee regarding community oversight. So one of the requirements is that, am I over time? Am I over time? I'm over time. Got a minute. But, oh, okay, it's red. Oh, it's just turned red. Okay, I got it. We have to have, you build a facility like this, you have to have community oversight. The plan is that the USOCB committee is the venue for oversight to this program. A discussion with Hetty Edmonds and others at NSF. It seems we have an existing structure. This will be the way that the committee will be the way that provides input. I happen to be the chair of that committee. I will be the PI of the program. I can't be both. I can't be the chair of the committee that gives me guidance, but we'll figure that out somehow. So the committee, to a large extent, we're meeting tomorrow night, will be the venue for input to the program, and the program will receive that input. And then for the community, the broader community, Heather has organized somehow we'll have a lunch gathering on Wednesday. We have a room right in here. Okay. So we'll grab lunch, and if people have comments, concerns, interest, whatever, I will be here with a lunch box on Wednesday or whatever, a lunch plate, and we can talk more about the U.S. Biogeochemical-Argo plan, which we hope will come to fruition. And with that, perfect. I'm done. Okay. So, whoops, that's my phone. I have two. One from Dave.
Yeah, Ken first, thank you.
Yep.
Good luck.
You want?
I have two questions. I'll yell. First one, to speak of radiometry, you said you have a downloading radius sensor. Is that a typical one that you guys have put in SOCOM, or has it changed?
Well, so SOCOM, the floats in SOCOM don't carry radiometers, but the default option would be Siebert OC50, OCR 504. Would be typically 3 wavelengths of light and R. But that is open for discussion.
Regarding calibration, calibration of the optics and probably chemical stuff and chemistry and everything. They're not long-term. These optics are not long-term instruments. What are you guys doing?
So, yeah, so the question from Ivona was, what are we going to do about long-term calibration of all of the sensors? So there,
I mean, like, I'm trying to find validation.
yeah. So first of all, we have a paper on the protocols that we've used up to date in JGR 2000, but the plan really is developing, and you can only calibrate the sensors when you deploy them. Otherwise, you calibrate against satellite data, right? For typically for the bio-optical sensors, which probably that would be an ongoing discussion. Yeah, I think we would calibrate from you rather than you calibrating from us.